We are back talking about streams, folks. Just saying, you know. Did you have enough streams for today?
No.
Yeah, okay, that's the right attitude, okay? So, hey, I'm Matteo Collina. Follow me on social media. I'm trying to compete with Vladimir. I'm joking. And the CEO. So, this talk is about streams. So, Node streams specifically, but also streams in general. As you probably have heard, I'm part of the Node.js technical steering committee. So, if you have any questions about Node, whatever, life, the universe, and everything in open source, just hit me. I'll try to answer. My DMs are open on Twitter, so please spam me, whatever. From time to time, you know, I even receive spam notification. That's fine. I work for a company called Nearform. We are a professional services company based in Ireland. We help companies all around the globe develop, deploy, manage JavaScript application in production. So we do full stack type of things. So yeah, let's get started. So, you know, you probably heard at this point in time what is a stream, okay? The answer to that might be it's a mess. Well, you know, this good analogy about streams, that streams is like an array, but over time. Streams enables us to process data in constant memory. That's a great thing about streams. We can process a huge amount of data with gigabytes and gigabytes and terabytes with just, I don't know, a tiny process of Node.js running with 80 megabytes of code. I wrote some code a long time ago that imported all of Wikipedia into a database, all of Wikipedia, in 120 megabytes of RAM. So that was pretty cool. That was Node 4 or something. OK. So yeah, that's what our streams are as a theory. Now, there is a catch. Who understands Node streams? Apart from this guy here and the guy next to him, and Paolo, maybe, I don't know where Paolo went, whatever, and maybe some other folks in the crowd that tried to read the code. Try read the code. It's an experience. Your life will be better after, maybe. You have seen with Matthias a lot of nice events for streams. And you know, there is a lot of nice things that you can do with streams, a lot of events you can listen to. You know, it's a very nice API, very well designed, and very, very thought for. You know, it was put a lot of time into designing this API. I'm responsible of this last bit here. I've added this, and I made a mess the first time that I added it. So, you know, just saying, Node 8, the Node 8 stuff is my fault. Anyway, don't use that. So back a long time ago, we had Node.js was just using on data, as you have seen. And you know, it's actually nice because you see on data and you pass in a function and you do something with that chunk, and then there is an end event, but then we know that that's not what it means, whatever. Anyway, we used to do this a lot back then. And it was, you know, a lot of people were happy about this, and that know what they were doing, but not really usable for everybody. So importantly enough, handling back pressure with this type of model was very hard. What is back pressure? So if I want to send you a ton of data, okay, back pressure is, you know, is you telling me stop, please, okay? And that's, you know, that's how push stream worked. Like when on data, you are flowing data out, and then you need to call me back and say pause, so I stop. That's hard. And a lot of memory leaks about this before Node 10 or something. Node 0.10, sorry. Long time ago. But after that, we got the readable event. Hey, with this readable event, which is pool-based model. Now, you have the same object that can even work in push mode or pull mode. How the mess can be inside. What the mess can be inside that thing. Again, read the code. And you know, you have this nice while chunk here, while, that was not even mentioned in the documentation since some time. And if you didn't put it in, you can actually leak memory again. So, just so that you know. So, that was the important part. This is completely unusable, though. The other model was actually very nice and easy, and this is actually way more complicated to use. So, yeah, okay. It's also more performant. And the reason why it's more performant is because we only read when we want. Okay, we only read when we want. It's not that I'm trying to push data to you and you're not ready for it. It's just you asking me when, oh, I can consume some data now. So that's actually nice. But it's hard to use. So again, what should I use in real life? Okay, none. Moreover, error handling is super complex. If you're doing it, use, as we said with Matthias, use finished, use pipeline. Error handling on streams is very complex. You're going to make a mess if you make it manually, so don't do it. And the worst thing that can happen is that if you try to run this code in production, I once did. So you can see here that you're doing this thing on pipe. You're using pipe, and I was running very similar code. What happens when that thing errors, when the res error, is that unfortunately you're going to leak a file descriptor and a tiny bit of memory, but the memory is not important. The important part is the file descriptor. After a while, your process will stop having file descriptor available, and then it stays up because it's not crashing. It just cannot accept any new connection. So use pipeline. Okay, you already seen this, so I'm not going to say anything new probably, but again, use pipeline all the time, or pump, or whatever you want. But just don't do it manually because you're going to make a mess. Or you can use a framework. A framework is good for saving files on the internet, okay? Or use Nginx, even better. Like, do something about it. Don't do it manually. Unfortunately, all the best features of Node.js rely on streams. If you use HTTP, you are using streams. If you're using FS, you are using streams. If you're using crypto, you are using streams. If you're using TLS, you are using streams. For everything that involves network and files and everything, you are using streams. So essentially, we are stuck with this thing. Every time we try to change something, we break 10 things. And it's after a while it settles, and then we want to fix another bug. One of the oldest issue on Node.js is 445, and it's issue 445. We are currently at 28,000 issues on Node Core. Issues 445 is the oldest one on streams. So just so that you know. But since when we started working on streams, async await happened. Okay? And you all love async await. Who hates async await? Oh, okay. You should join the bandwagon, folks. I turned.
I kind of hate it still.
You turned, like myself. Unfortunately, this plays bad. All this stuff plays very badly with async await. As a rule, if you're not using what I'm mentioning in this talk, never mix streams and async await, ever. Okay? That's a rule. In this talk, we are going to deal with this. They don't work together at all. Okay? Let me repeat this. Do not mix. Otherwise, you get popcorn. Be prepared. Also, I don't want it to make a lot of popcorns, but so I also don't want to, break everybody. Like every time before doing a Node release, one of the things that we do is we run Node through Canary in the gold mine. What is this tool? This tool takes some of the most significant packages on NPM, and we run their test against the new version of Node. Why we do that? So we can spot if we are regressing on anything. And we regressed a lot, in a lot of cases, because if you try to run that, and if we break a very popular package like ESLint, or React, or Webpack, that's a problem. Okay, I broke Yarn twice, so just saying. As a Node Core collaborator, we see a lot of questions about Node streams, and the usability of Node streams of these APIs is not there. Okay, so how can we improve the usability of Node streams, especially in an async await world, right? A lot of folks love async await, and they want to use async await with streams, and they are making popcorn. So I've seen a lot of that code. There is this other thing that happened, though, and since Node 10, which is async iterators. Now, these more or less, not a lot of people talked about async iterators in Node 10. When Node 10 came out that shipped this. This is a new feature in the language. And it more or less sneaked in, and not a big buzz about it. But it's fantastic. Let's see it in a second. So async iterators, what they do is you can create a function like this, which is an async generator, which you call yield. Then you can use await and sleep, or do whatever you want here, any promise-based API. And then you can consume that by using for await, let chunk of iterator, whatever. Okay? So we can consume that asynchronously. This looks a lot like a stream, though. Doesn't it? It's an array over time. That's beautiful, right? It's just JavaScript. Like, I haven't written any Node magic here. That's just JavaScript. It's cool. So as part of the stream working group, we have been working with TC39 to ensure that async iterators could be compatible with Node streams. We could support, we could convert async iterators with Node streams to Node. We could convert Node streams to async iterators. So, and we have been involved a little bit when they hit stage 3 and so on. I don't know if you will know the TC39 process, so check that out. Anyway, we have been in touch and we have done some experiments and yeah, no, this can work. So since Node 10, you can do this. They've been experimental since last April, May, and we just removed the flag in Node 12. And it's basically, you can consume a stream just using plain JavaScript. You can consume a stream just using for await. It's pretty cool, right? It's a nice thing. It's a nice API. It's way simpler to understand than both data and readable, right? And I can use async await and promises, and I have enter a word of broken promises. It also does a render write. So if you throw in there, it's going to destroy the stream, so you're not leaking memory. Okay? So it's safe. And it's really cool. In Node 12, we have also recently added readable from, Node 12.4, the latest version. We just shipped this. We have added readable.from, which you can pass a generator to get, an iterator, and an iterator that you can use to create a stream from. So you can use JavaScript just to interact with streams. And you can pipe that. You can also use an async generator if you want that. There is it's a lot of things. Generators, async generator, async iterators, well, a lot of async stuff. A lot of stars anyway. So again, we can generate one thing using JavaScript and then iterate over it. Pretty cool. So it's time for a demo of all this stuff. So, whoa, okay, this is tiny. So let's zoom in. I hope this is big enough. Is it big enough at the back? Yay, okay. So demo. So let's see if my first example is very tiny. And I'm just showing the old way if I want to generate a stream with a readable. Now, there is a fantastic module from Matthias. Matthias is always a module called from2 that more or less does the same thing. But if you look at this, you will see that you get it's complex, right? And there are a lot of subtle ways. Like this code in Node 8 does not work. Just so that you know. You don't want to know why. And Node 6 and all the before. I got fixed that in 8 or something. Maybe it was 10. Sorry, it was 10. Hmm?
Use readable stream.
Yeah, use readable stream, folks. Okay, I maintain that, by the way. Fourth module it's the fourth one. It's the fourth most downloaded module on NPM. So my NPM credentials, by the way, have value. So don't try to hack me. So if we run this, what the output of this code is just what we expect. So we print all the values. Now we can rewrite these using this new stuff, just using readable from. Hey, this is nice. So, and it still works the same, and we are happy because we can have just reduced a lot of boilerplate, right? We can also use a generator, as I showed before. So we can actually generate stuff and just, pipe that and just pass that in. So again, still is fine. I'm printing a lot of numbers in this demo. I don't know why. So I had no ideas. So as I said, we can do this type of things where we are consuming it and using asynchronous stuff. I'm not running this because it's whatever. As I said, again, you can do the same thing with async generate. So we can actually run this and it works exactly as you would expect. Like, same thing, it's fine. Okay, so they all work the same and it's exactly the same way things are set up and you would expect. You're just using plain JavaScript instead of obscure Node API that only a few people understand truly. So at least we are abstracting away some of the complexity. So now this is good. This is more interesting though, because we can process a large file just by getting strings, okay? Just by reading the file. So I can run it and it just works again. And we can even edit this very quickly and say, well, these are strings, so I can do 2 uppercase. And then I have uppercase, okay? And it's very tiny, but still, if we needed to do that by using a transform stream, that would have been way more complex code. And instead, I can just use plain JavaScript to do my processing, this makes it for great data processing pipelines. So this is a more complex example, okay? Because I wanted also to show a little bit of more complex stuff. So let's say that we have now, for example, HTTP request and response are streams, right? And HTTP requests inherit from readable. Given that HTTP requests inherit from readable, you can actually async iterate an HTTP request automatically out of the box. You can do it now with Node 10 and 12. So what you can see, what you are doing here, we are getting, so couple of things. This is your create server, okay? You get a request and a response. And first of all, we call this other function and we put a .catch handler. You know why we put a .catch handler? You had a 30-minute talk about broken promises, okay? Folks, please, put your catch handler in place, otherwise you're going to break your promises. So then you have, the first thing, and then we call this print function, which the only thing that this does is compute the total number of characters and returns that. Okay, and let's see, you see that we are doing for await. And we are just processing this, just pure JavaScript. We don't have to deal with on events. We don't have to deal with finished. We don't have to deal with a lot of the complexities that are inherent for streams. It all works, and is guaranteed to not leak memory. Okay? We are handling this for you. So what are we sending? Well, we are sending some. We are sending the same file. Okay? So we are sending our current file up. Note. You can see how ugly it is when you can't use the stuff. Now, you see this thing? We do rest pipe and finish it only on rest. Do you know why? Matthias, you probably think about it. We can't use pipeline here. It's just it's one of those 10 things that you didn't mention during your talk that you didn't like. Okay? That's whatever. So anyway, let's run this code. So what we do, and automatically done, it's receive the number of characters that we are receiving. So, and that's it. So that was my demo about the stuff that we have added so far. What is missing? Because I showed something. I showed some examples, some async iterator stuff, some other things, but I've not showed you that there's not the full stream API available in this way. What is missing right now? So first of all, transform is missing. We don't have a transfer equivalent for async iterators. Now I have prototyped an API this doesn't exist, this doesn't run. Maybe it will hit Node.js in the next few months, hopefully. It's something that needs to be worked on. And but it provides a nice way to write a transform stream, okay? And we can provide it maybe with transform.from, and we get the transform. That might be good. There might be something else that we can do. In fact, we can do probably something better. We might even just add it to pipeline, so that we make pipeline compatible with these protocols, so we don't have to even allocate a stream. Every time we allocate a stream, we introduce some buffering. Every stream has its own buffering, because it needs to do back pressure, right? It needs to do. And if we are doing this, we are relying on our parent back pressure than on our parent buffer. So we are actually less exposed memory-wise. So it's actually nice. But again, this does not exist. It needs to be done. Then we enter the ugly world of writable. Async iterators are useful for iterating over things, not really for writing on stuff. This is a question that is open. I've written some code. In the next slide, it does work. I'm not happy with it. So this is an example of a function that take an async iterator and write something into a file. And essentially, it uses this magical build write method to get a write function that we can await on and returns a promise. And then we await on finished to know when the destination has finished writing, because we want to know when that has actually flushed. Now, the magic is this build write function. And this build write function is implemented like this. And it's some code that it's doing a lot of things, and it's dealing with errors specifically. There is a problem, between streams and promises. One of the real problems why they clash so badly is because streams emits errors whenever they happen, at the moment that they happen. Promises rejects when you open the box, when the cat can be dead or alive, and you just open the box to know if what's the actual state. You don't know. A promise is pending, is not settled. The promise is pending until you look into it. And this is a major difference between the two models, and why it's so hard to reconcile. And that's why it's so hard it's why it's so simple to make popcorn with streams and async functions. So, and all of these deal with all that jazz. It's just not really nice looking, and it's not. I'm looking for ideas, okay? And I'm here. Talk to me. In implementing some of the stuff, I learned a lot of things. So maybe it's good to share a little bit back on this world of magical async iterators. It's all JavaScript, folks. Like it's nothing special. In fact, the async iterator is a protocol. So when you pass an object to for await, it's actually going to call the async iterator protocol that V8s implement. What's a protocol? It's essentially a set of functions attached to an object that are going to be called. So how do we implement it in non-core? Essentially, you just or on your code as well. What you need to do is you just need to attach a symbol.async iterator property. That's a function that returns the iterator, the async iterator. It's that simple. It's like implementing an iterator, but this is async. This is as simple as that. And this is the actual protocol and how we implement it in Node Core. Now, this is omitted and simplified. I will show the full thing in a second, but I just want to point you to this block. So first of all, async iterator needs to inherit as this thing as a prototype at the top. Otherwise, it's not spec compliant. Let's start TC39. I don't know why. And basically, we set these as the prototype of this other object, which has three things. Well, this is because we need it. And this is the next and return. So next will be called by the loop to get a new object, and it needs to return a promise. And return will be called by the loop when you exit the loop. So you can, even if you throw or in any way. In this way, we can use the return method to actually destroy the stream and clean up the resources, even in case of an exception. It's guaranteed to be called, even in case of an exception. It's really cool. Moreover, in async iterators, we wrap the readable event. We are not wrapping on data. We are wrapping the readable event. So in fact, we are only reading from the stream when next is called. So we can actually support await and keep the same properties of streams of processing data in constant memory, which is pretty cool. And we can do this without allocating a new internal buffer like a transform string is doing. So this is actually very powerful because we can avoid a lot of work. This is the URL of the implementation. So I'm going to open it up, and hopefully, I did it wrong. Where it is? Yay. Okay, here it is. Okay, so let's zoom in. This is a little bit of a big thing. Note that we depend on finished. Thank you, Matthias. There is. So this is how Next is implemented. Okay. Note that we have some error handling, and we actually return early if it's ended. Whenever you return anything from Next, you need to return an object which is value, which has two properties: value and done. Value is the value, done is the stream finished. And then we enter this thing, you need to check if the stream is destroyed. Because every time you need to update anything, you need to check that public property, just so that you know that's not rocket science. Then we do a little bit, there is a big comment here that explains this. I don't remember why, but, a lot of comments. And, in order to make this fast, we are avoiding to create some closures here. So essentially, that works. And, it's a long stuff. Anyway, I just wanted to show this is not super simple, but it's doable. It's just JavaScript, folks. So the nice part about this is there is no performance penalty in using async iterators versus on data. So it's actually fantastic. It's really, really cool. So this is the nice part. I'm a performance person, so I love making things faster. I love making nodes faster. So this is actually really, really, really interesting. There is also another thing that I want to talk about that ties to async iterators, which is what working group streams. Now, what working group streams is it's another stream implementation that was born after the Node one. And we did the streams, then the web decided, oh, we need streams as well, but we want them based on promises. I don't want to enter that. There's a lot of bad blood being spilled into all of that. That's a closed discussion. What.js streams have this type of concept of pipe to that you use to pipe from one to another that does error handling, blah, blah, blah. And it's all based on promises. That's cool. The reason why this is important, though, is that the web platform use what.js streams as the basis of fetch. How many of you use fetch? Hey, okay. Do you use it on? Do you use node? How many of you use node fetch? Okay. So you know that node fetch is not compatible with the spec, right? Node fetch is like more or less the same thing, but implemented on top of node streams. So anyway, the web platform has these things called fetch. And with fetch, you can call an endpoint on the remote endpoint and process some data using in a streaming fashion. I copied this code from MDM, by the way. So, it's complex, right? It's and we can use await and so on and so forth. It's complex code, okay? It comes to me that all streams are super complex. Like, it's not that just Node streams are complex. Like, what would you stream at least were designed, so they have a nicer API that's not a total mess, okay? But they can change them anyway. So there is a lot of interest in getting what.js streams into Node. Because they're part of the web standards, they want to use them, for example, also for workers and other things. So it might be interesting to get them in core. There is fetch. That's a topic. That's another topic. So if you want to talk about fetch, I can do another half an hour on fetch. I did an hour on fetch at the Node.js Collaborator Summit last week, and that's a big topic. And and all possible future use case. However, the main problem in adding these to Node core is the ecosystem compatibility. Like, you can't do this specifically. Like, all the things on the internet on npm are using Node streams for Node, and they're using what.js streams on the web. But if we want to say, oh, we cannot just come up and say, oh, we just replace all Node streams with what.js streams. Yeah, no, that won't work. Okay, we are breaking everybody. So the main problem is adding to Node core is ecosystem compatibility. And that is hard. There is a huge amount of modules that do a lot of things for Node streams that won't be available for the new ones. So, however, what.js streams are going to be async iterable as well, with more or less the same semantics of Node streams, because they are essentially the same thing, right? So I hope that in the future, we will just be able to use pipeline to pipe them one next to the other without doing anything. Okay? That's the future I want to believe in. And maybe this code does not exist. Okay? So if you want to get involved, Node.js is always looking for new collaborators. So, if you want to work in a very friendly and welcoming open source project, please contact me. I'll hook you up and try to get you into the crowd. So I am almost done, likely, and I work for this company called Nearform. We are based in Ireland, but we are in fact in 24 different countries. So we are remote and distributed, so everybody works from home. I do travel a lot, though. Not everybody does, though. And we are hiring. So anyway, so that you know. And go eat our website, and all the details there if you're interested. And thank you.